Hey guys, so now we're in chapter 3.2, range and standard deviation. So let me go ahead and bring up the PowerPoint. Oops, close that down. Okay, so here we go. So we're talking about measures of dispersion, which means it's how spread out the data is. So we're going to calculate the range, variance, and standard deviation. So let's go ahead and talk about the range. The range is really easy to do. It's your maximum minus your minimum. So if you have a bunch of data, like let's look at A. So it's your maximum times your minimum. They're not in order, so you got to make sure that you look for the max, which for that one is 44, and the minimum, which is 2, which makes it 42. How about for the bottom one? It's 44 minus 2, which gives you 42. Okay, so they're both 42 for that. Okay, standard deviation. Okay, think of standard deviation is, okay, you're going on a cruise, and the travel agent says, okay, the mean age of the people on this cruise is 25. Well, that's great. Say you're like 24 and you want to go meet people your own age. The better question to ask is, what is the mean and the standard deviation? Because the standard deviation is a measure of how we might expect a typical member of the data to differ from the mean. And you're kind of looking at standard deviation of how far it falls from the mean. So if I said, okay, you were on that cruise and your mean was 25 and you had a standard deviation of 5, then you could say, well, a bunch of people would between 20 to 30, because you're going to add the standard deviation to the mean and subtract it from the mean, so 20 to 30. And you might even have people from 15 to 35 as you go away. So that's not a big spread. But if your travel agent said, yeah, the mean's 25 and the standard deviation is, say, 10, well, you might be running into some problems, because then you have a huge range, because then one standard deviation would be 15 to 35, and then another one would be 5 to 45. And if you're looking at people in that range and you want to meet people in your same age group, you want to go with a smaller standard deviation, because that means your data is not as spread out. So that nasty formula below is the population standard deviation, and we say that is S. Don't worry about all the formula, okay? But do make note, see that capital N? We saw that before when we were looking at means, and it just means everybody in the population. Okay? So here's the sample standard deviation, which is S. And you know what? The population standard deviation is wrong, so ignore that. It should be a sigma. So let's look at the sample standard deviation. Its S equals the summation of x1 minus the mean squared over n minus 1. The only difference in the two formulas for population and sample is the n minus 1 on the bottom and the n on the population. Because in the sample, you're going to subtract by 1 on the bottom, and the population you don't. All right, so let's look at this. Calculate the sample standard deviation of the following data: 5, 8, 7, 6, 9. So we're going to show you how you do it by hand. And it's kind of nasty. There's a way to do it. But you know what? We're never going to do it by hand. We're going to do it in the calculator. So remember how you found your mean and your median in the calculator? It's the same way. You're going to do stats, option 1, enter. L1, remember, put that data. If for some reason L1's not showing up, I sent you an email on how to reset your calculator, so use that. Hit stat again, calc, and then hit 1 bar statistics, and hit enter twice. So let's look at the output, okay? X bar is 7, which means that's the mean. Ignore this, sigma x squared, but go to SX, where it says 1.58. Since the data was since the data had no decimal places, we're going to take the standard deviation out 1 to be 1.6. So the 1.58113,883 rounds to 1.6. Take note, underneath it, that is the population standard deviation. That little, it almost looks like an O. So the population is different. It's 1.4114. The difference, remember, in the sample and the population is in the population, you're just dividing by everybody in the population. In the sample, it's everybody minus 1. Okay, so where does the formula come from? You have to think of the standard deviation as a sort of average distance of the values in a set life from the mean. It's not actually the average. It's very close to the average, and it's a good way to think about standard deviation. So you have to use the mean to find your standard deviation. Okay. We're not going to really talk about the formula that much. I just want you to know the standard deviation is a quick way to see how your data is spread out. All right, so here's 2 examples. It has a data value, and the first one it wants you to give you, assume that the values represent in age and years the patients randomly sampled from an urgent care clinic. So what word is there? Sampled. So you're going to treat this as a sample. So you're going to put it in your calculator, and you're going to look at the SX. And then B says, assume the values represent the age of all the patients seen by Dr. Dabbs in one afternoon. So you see all patients. So we're going to look for the population. Remember, the population standard deviation is right under the sample standard deviation. So here are the calculator instructions again, and let's look at the output. So the sample you see is 15.888. So I'm going to make that 15.9. The population is 15.2. Okay, so it shows you what they're doing. Okay? All right, so here's another one. Mark is looking to invest a portion of his recent bonus into the stock market. While researching different companies, he discovers the following standard deviations of 1 year of daily stock closing prices. The first company's standard deviation is $1.02. The second is $9.67. What does the 2 standard deviations tell you about the stock prices of the companies? Well, let's look at that first one. That one's not a lot. That's not a huge standard deviation, but the second one is. So remember, a smaller standard deviation indicates the data values are closer together, where the larger one indicates that the data are more spread out. So you could say that there's less variability in the daily price of the first one than the second one because the standard deviation isn't larger. So if you knew, okay, remember the standard deviation can be on both sides of the mean. We're going to see this a lot later in this chapter when we talk about empirical rule. A smaller standard deviation means it tends to stay around the mean. A larger standard deviation means it can be spread out below the mean and above the mean. So if you want a better long-term solution, go with the first company with a smaller stock price of 102 for its standard deviation. If you're willing to bet everything and you want to see if you can get something that's going to go high, then you want the second one, because that $9 is a lot more than that $1. But you can also lose that much too. Okay, coefficient of variation. This one is throwing a couple of people. Coefficient of variation for a set of data is the ratio of the standard deviation to the mean as a percentage. For a population, it's given as CV equals S over N times 100, where the S should unfortunately be the little symbol down there that looks like the 0, or O, it's a Greek letter, and mu is the population mean. So here we go. And this is for sample. Basically, it's the same formula, guys, so don't worry about it. Where S is the sample standard deviation and X bar is the mean. Okay, so here we go. Suppose that graph A from figure 3.1 represents the average amount of rainfall for a sample of farms in the United States, and graph B represents the price of 20 acres of farmland for the same farms. The mean and standard deviation of the data set A is 26.08 inches and 7.55 inches, respectively, where the mean and standard deviation is, 117,000 and $42,931. Which graph has the largest standard deviation relative to its mean? All right, so we're looking at something. We're comparing rainfall, which is in inches, to farmland, which is in money. So you're like, how can you compare those two? But you actually can. So here's the graph. So we're looking at it, hey, A looks pretty nice and symmetric, and so does B. So this is what they look like. So let's start doing it, okay? So A, we put 7.55 the inches of the standard deviation, it's the sample standard deviation over the mean of 26.08. Multiply that by 100 to make it a percentage, and we get 28.9. For B, we put the standard deviation, which is $42,931 over $117,000. Times 100, we get 36.7. So 28.9 compared to 36.7. So data set C has a larger standard deviation relative to its mean. So that means there's more variability in B than A. So think of it this way. The larger the CV, our coefficient of variation, it means the larger the variability. The smaller the CV, the less amount of variability. Okay? I'm going to stop here and we'll go on to variance in the next thing. Thanks.